Okay, here we are with our second free response for this packet, and this again is it's the second one. The first one was calculator. This is another one that's calculator, and you're given one of these table things, and I think you should really hope for one of these table problems because generally the questions they ask are fairly straightforward and fairly predictable. So first question here, you've got, well, first of all, let's check it. We've got G is games per week. It's talking about tracking the sales of board games over a 12-week period. So here's week 0, here's week 12, and they're selling, 160 games in the first week, and by the end of the 12 weeks, they're selling 2,400 games in a week. So it does say that G is differentiable, which means this thing is obviously continuous. There's no breaks in time between 0 and 12. And it must make a smooth transition. The rate's a transition at a smooth rate. So the first thing it's asking to do is approximate the value of G prime of 8. Well, that's asking us for the rate of change of G at 8. Well, 8 you'll find is right in between 6 and 10, and this is a really common question for them to ask. And I promise you it'll always be a number that's right in between two of the numbers on the table. So all we have to do is basically estimate the slope, because of course that's what G prime means, of G at 8. So what we're going to use is 10 and 6 as our data points, and we'll say G prime of 8 is equal to the rate of change between the point 10, 2100 and the point 6, 900. Those are our two data points. So I'm just going to do 2100 minus 900 over 10 minus 6 and get our answer. I think that's 1200 over 4, which is 300. Now, the units here, we have games per week, and then that's changing over weeks. So this numerator is games per week, and the denominator is weeks. So it's going to be games per week squared. It doesn't ask for the units, but it's so easy, you may as well toss them in there. It says show the computations. That means just show the slopes, show the difference in the y's over the difference of the x's. That is an absolute gimme, and I think we probably just picked up 2 points there. All right, for the second part, I took the liberty of drawing this little graph here of what this stuff is. It doesn't matter that it's not drawn to scale or anything like that, but it's going to help us understand that if they want to integrate g of t from 0 to 12, basically that's the area under g of t between 0 and 12. And so what we have are these data points that are going up as we move from 0 to 12. And it says use a right Riemann sum with 4 subintervals indicated by the table. Well, that just means use the intervals that they've kind of set forth for you. And a right Riemann sum means we're going to use the right side of every rectangle. So for this rectangle right in here, this last one at the end, we're going to use the height at the right end, which of course is 2400. And that area would be the height, which is 2400, times the width, which is 2. So we would get 2 times 2400. That area is 4800. Now, let's go and get the next rectangle down. So this one has a height of 2100 and a width of 4. So it's 2100 times 4. So 2100, and we're timesing that by 4. That, of course, is, let's see, 8,400. And if you're not good at quick arithmetic in your head, use your calculator. This one is 900 high by 3 wide. So that's 900 times 3, which is 2,700. And then lastly, this little guy at the end is 450 high, and he is 3 wide. So I think that's 1,350. And then all you have to do is add those guys up and to get a number. Okay, so I finished this problem off here. Added those numbers up and got 17,250, and then it says explain the meaning of that integral in the context of this problem. Well, again, because G was games per week, and then the x-axis was weeks, games per week times weeks is games. So it's the total number of games sold during the 12 weeks from t equals 0 to t equals 12. And again, I talked to you about before, make sure you include those limits in your explanation. So there you go. Pretty simple, number 1 and 2. Okay, this part C is probably the trickiest, definitely the trickiest part of this question, because the data from the last from the chart leaves us off at t equals 12 and us selling 2,400 games per week, and that rate is going to increase at a constant rate of 100 games per week every week. So now they're saying how many total games are going to be sold during the 8 weeks from the time t equals 12 to t equals 20. Well, intuitively, I think it's pretty clear how many total games are going to be sold. You want to do an integral from 12 to 20. So that'd be the first thing you'd want to do. Probably you're not going to probably get any points for just those limits, but it's a good way to start. And now, if you want to think about our rate that we're trying to model here for these next 8 weeks, we know already it's 2,400 because that's where it left off at t equals 12. And with every week that passes, it's going to go up by 100. So your inclination might be 100 times t, where t is the number of weeks, and you're going to go up from there. The problem is, if you put, for example, 12 in this thing for t, if you did r of 12, you would be multiplying that 100 by 12, and that would increase the rate at time equal 12 by 1,200. That would be 2,400 plus 1,200, which is 3,600 at 12 weeks. That we know that's wrong because we know the rate at 12 weeks is only 2,400. So what we have to do with that is deal with the fact that this is only in effect for weeks beyond 12 weeks. And so the way you fix that in algebra is you do a little subtraction there. You say, okay, it's 100 t minus 12. And what that's going to do is only get this increase of 100 per week for the weeks bigger than 12. So now if you put in 13, that's going to get you the 2,400 plus the extra 13 minus 12, which is 1, extra 100. So there's your rate function. And because we're looking for the total number of games, we would just integrate that guy. So I'm going to put a 2,400 plus 100 t minus 12. Put some brackets around that and put a dt at the end, and that's the integral we're going to need. But again, it's a calculator question, so we'll just toss that in the calculator. Okay, so running that number, I just did the math 9 option for the integration because we don't need a derivative on this or anything like that. Got 22,400 and wrote a sentence here and said based on the model, because that's what it says, based on this model, there will be 22,400 games sold during the 8 weeks from t equals 12 to t equals 20. Again, using those limits in my explanation. Doesn't say explain it here, but couldn't hurt. So lastly, this is really the same question. Oh, back to this part though. Like, that is pretty tricky. I could totally see in the heat of the exam totally forgetting about this, or maybe forgetting the initial 2,400 that the thing starts with. So it is what it is. If you blew that and you don't pick up these, I think this is probably worth about 2 points. If you didn't pick up those two, that would be, not the worst thing in the world. But this last one is the same exact concept, except they're giving you an explicit function. You don't have to come up with this anymore. And they even put a little hint in here for part C. Notice how they have the time t minus 12. So it's kind of giving you a hint about how you could have done letter C. So this one is the same thing. It's just somebody else has this model to use, and they want to find out the total games per week from 12 to 20. So this is just going to be a straightforward integral from 12 to 20 of this exponential function, 2,400 e to the negative 0.01 t minus 12 quantity squared dt, and just throw that directly into math 9 and get your answer, which is 15,784.077, but it does say to the nearest whole number, so we would say 15,784 games. And again, it would be based on this model, just like we did in the last part. There will be approximately 15,784 games sold during the 8 weeks from t equals 12 to t equals 20. So there you go, all four parts, A through D. Nothing too crazy there, except for this t minus 12 thing. I think that's a little bit hinky. But there you go.